Hey, Gopu.
Hey Zane, what's up? How are you doing?
Doing well. Your hair's getting so long.
Yes, no,
Yeah,
it's
you
all
cut. I think
bad.
last time, um, before we, before I left UTSA, you cut it real short.
Yes, I did. It was uh, it was during the pandemic, and
Mm.
so it was just after I moved from Japan. The water here was shitty as fuck. I cut it all completely. Now I'm growing it again. How are you? How are
Really?
you?
Oh, doing well. Midterms,
Oh yeah.
middle of the semester, so we're in the middle of it. But
Any plans for the spring break?
gonna do some traveling. We have
Nice.
some sick kids at home, and so trying to get everybody well for that and feeling better. So,
I would like to go to Big Bend. Let's see if I can before it
oh,
gets.
that's nice. I bet it'd be real nice this time of year.
Ah, I want to go before it gets hotter. Mm.
Yeah, yeah, yeah. Yeah, that's one of my favorite places. Um,
Have you been
on
to Terlingua, that ghost city?
oh yeah.
It really looks like Mars.
Have you been there?
Yeah, many
Yeah, I
times.
love it. You go, there's a bar, nobody's ever in there, and you go and they'll have Totino's pizza, frozen pizzas
Really?
that you can order. Yeah, it's so small that it's just a frozen pizza behind a bar, but you get a like a real cold Lone Star beer and frozen pizza, and it's great.
My favorite part is taking a gummy and just watching the night sky. Oh, it's
Oh yeah. I mean
oh,
it's so dark. Gosh. We did a star tour, so the
how
McDonald
did you?
Observatory. Yeah, a couple summers ago. They'll do there's a big observatory out past Fort Davis in the Fort Davis. And it's University of Texas facility, the astronomy department out there. And so there's faculty and grad students out there. And then you show up at like 9 o'clock at night and then you stay there and they literally have laser pointers and they point, you can see all the stars. It's amazing. And then they set up a bunch of their telescopes and you walk around to their different telescopes. I mean, it was such a great experience. So
Do you make an appointment with them?
no, I think they over the summer they do it like every Friday night or something. They'll post. You just have to hit the weather because sometimes if it's a cloudy night, obviously they're not going to do it. But it's I we want to do it again, so it was great.
I think.
So today we're going to talk about this was a topic you came up with, and
Yes.
so I had to do a lot of. I mean, I'm vaguely familiar with it. I was vaguely familiar with it. I had to do a lot of research, but transcranial magnetic stimulation. What got you? What was the? Why did you want to look at this?
Because honestly, a family friend, we were having brunch on Saturday and we were just talking about, how we're doing and all that. And they were the first one to tell me they were going through or they were, they underwent TMS and they were telling about it. I mean, I had come across this term TMS, transcranial magnetic stimulation, here and there,
Hmm.
but I just thought it was another snake oil, because these days there are like 10 million kind of therapies. There is a therapy for every single one on the planet. So I didn't know how legit it was. But then I kept on, I don't know, it just somehow kept on popping up here and there. Then I just wanted to know what actually is this? Like, what is going on? Like, what are we stimulating?
Did
What
it? So
is
what were they getting treated for?
depression?
Did it help?
They said it did. They
Okay.
said it did very much.
Yeah, this is one of. I mean, I totally sympathize. This is my same exact perspective of I hear about it. I actually had a student that worked. She was a technician in a clinic that did it, and she talked all about it. And I was just like, whatever. This is one of these like snake oil things. And she said, no, it's people really do get better from it. Eye roll, whatever. So I think I've always kind of brushed it off as well as like a legitimate, I mean, first of all, just a legitimate thing that works. Like not in terms of like improving depression or whatever, but like actually changing the brain. Like it's but I don't know. I mean, I've this definitely opened my eyes kind of digging through some of the research. So why don't you
In,
take like
yeah,
before we jump in, why don't we talk about specifically what it is so anybody listening has a good idea.
yeah, sure. So, do you want to? Should I?
You can do it. This
Okay.
is your
So,
interest.
fair. So from what I understand, this transcranial magnetic stimulation, to be very specific, it depolarizes axons in cortex, or what that means is um, it uses magnetic coils, and you just place it above your head, and with that you can either activate or silence neurons. They say neurons. I
Hmm.
think more happening, but we'll come to that. Neurons, and thereby changing the excitability and activity of these neurons. You control something big like depression, mood disorder, substance use disorder, etc., etc., etc.
Hmm. Hmm.
So from what, the videos I've seen, papers I've read, what I think is it's like going to a dentist's office. So you go there. So if I'm undergoing this procedure, I would go to the office, um, sit in a chair. Everything, the whole setup looks like a dentist office, really. And they just keep something that looks like a shower head in
Yeah, like a shower cap. Yeah,
pretty
yeah.
much,
Yep.
and then keep it whichever region of the brain that you want to target. And then you pretty much expose it, I guess, somewhere between 20 minutes to 1 hour, I guess.
Okay.
Like within a specific time, not more than
Yeah.
1 hour.
Yeah,
And
yeah.
then they say that you would have some dizziness, maybe see an aura, headache, whatever, like a minor discomfort,
Hmm.
maybe a gentle tap, and after that, you are good to go. And
Hmm.
therapy usually lasts like it's like sitting, getting a tattoo pretty much. So first you have, I think, for 5 weeks, you need to do every day. Every weekday, pretty much. I would say Monday to Friday, every day you do for 5 weeks. Then you taper off, then again you taper off. So it's like a phased out.
Hmm.
I don't know how long it is meant to last, this antidepressive effect's meant to last.
Okay.
So after some time, I think you need to do it again from what I understood. But it is pretty much okay, again. So this is because you have that shower head of a coil. You are concentrating the magnetic effect of that coil in a particular part of the brain. Since it's magnetic waves, it's not penetrating deeply. So the region of interest or region of modulation is just cortical regions for now.
Hmm.
And then you change the magnetic, pretty much you fuck it up. Fuck it up in the sense you change all the, connections and all that. Connections are too vague of a word, but you just change conditions, I guess, over there, and you say how that affects.
Yeah, so I think in the way that I've kind of started to understand it, I really am not clear on this specific mechanism of like
Same.
how it changes the neuronal function, but they do appear to have like two different settings, like a boost setting and then like a suppressive setting. Like you said, you can kind of turn things on and turn things off.
Yeah.
And I think that's dependent on the frequency of the magnetic pulses,
Yes. Yes.
right? And so I think, and this is just from my own background, my own neuroscience background, is that they're using these low frequency pulses, like one pulse a second, to really, I guess the best word I can think about it is entrain those those brain waves,
Mhm.
right? And so if you've got a brain wave that's too fast, whatever that may be, this is where I get very this is where it becomes very vague and hand wavy and snake oily. Is like, does fast brainwave mean depression or does fast brainwave mean anxiety? I don't think we can conclude that, but it slows it down, right?
Even
So you
here,
slow
right? Like,
down the rhythms of that brain region. So they can target it like to say, all right, you need to target this area. Let's slow it down, right?
so when we talk about again brainwave, are we talking about population activity of neurons? Like what are we even
I
wave
think
can
that's for me that's the best way that
I agree,
I
yeah.
can conceptually understand it, right? Is that they are looking at the oscillations of populations of neurons. And now what I don't think we know, and this is as a neuroscience group at large, is like, what does that mean for the brain's response to a neurological disease, right? So, like I said, depression doesn't necessarily mean you have slow oscillations, right? Right. Epilepsy and seizures, right, have different
Either way,
operations. And so
right?
I think there is something there that I'm missing to really get on board with, but maybe that's the gap that we need more insight.
One
But
of
you
the
tune it, right? So that you can go high frequency and low frequency, and they can use that to target different areas. And so I think that's kind of cool, right?
Is it? Because I don't know, because my problem with this is it's just like you were saying, it's cool that it does something, it's great,
Hmm.
but it's the complete lack of specificity for me. And and another noted side effect of TMS is seizure, because of course he was
Hmm.
screwing up the, I don't
Yeah.
know the exact word to use, magnetic resonance, I don't know. Like that population activity of cells in cortex, of course you're going to get seizure. What do you think? But I don't know, it's just the lack of specificity for me, because yes, you can target a population of axons, but cortex have different type of cells at different concentration, different, like we are at a stage in science where we are discovering new cells in the brain almost on a daily basis,
Hmm.
with all that, with all the different receptors, with all the different ionic channels, so many things going on, just showing a pretty strong magnet on the head,
Hmm.
and just
So I will say, and I think this is maybe one of the reasons it's becoming more and more popular, is that there is a shift in neuroscience now where we are starting to recognize the difference between the activity of a single cell, right? It's if you just look at its firing properties, its action potentials, how fast it fires, how fast it communicates, that is different than quote unquote these population level functions, right? These oscillations, these brain waves. We are really starting, and this is a technology thing, really starting to understand what those emergent properties of these networks are. And I think this may be one way. I mean, there's so much. I mean, this is not a new field. They've been doing this for almost 40 years now, right? Um, but maybe it's a way instead of individual, like, I don't think you can change the activity of one cell and influence the whole system. I think you have to change the population level. And so by pulsing these magnetic frequencies, you're changing all of those neurons, you're changing all of those cells, right? Inhibitory neurons, excitatory neurons, glutamatergic, dopaminergic, all of these neurons at once. But maybe it's a large enough manipulation that the system can actually deviate. I find the brain very difficult as a system to like push and have it respond in a way that you can predict it. And this may be one of the ways that it is non-invasively able to do that. Of course, you can inject electrodes, pass large amounts of currents in, and change the way that those brain networks function. But this is a little bit different. It's not invasive. You don't have to do a surgery. You don't have to drill a hole, right? You can just put a hat on, a shower cap on, and then pulse it in a direction and can change it. And the nice thing about it is you can ask the person, like they're awake. Hey, what do you feel? Oh, I feel nauseous.
but in the,
So it's
to
doing something, right?
continue on your train of thought, in 2 3 episodes before we recorded the implantable devices in the brain, right? Can you
Mm,
we can do the sub, because one of the, what is it, one of the limitation of this is the, it's only limited to cortical areas, right? You can't just go deep in.
mm,
With this, with a deep magnet in, man, the possibilities are endless, I think. And not just that, like when we speak about activating neurons, I was I mean, brain is not just neurons, right? Like 50% of the, more than 50% is other cells. So I was looking at least with astrocytes, does it have any effect? Like what does it do
Hmm.
in response to these MRI, not MRI, what is it? TMS. There is a pain model that shows that T chronic pain model, TMS reduces secretion of pro-inflammatory factors. It
Hmm.
has, what is it? It, of course, it changes gene expression. And notedly, it reduces gliosis. It
Hmm.
reduces proliferation of astrocytes and microglia. And not just one, there are many, not many, many is relative. There are like handful of papers that's published by different groups in mouse and rat models that show particular dose of
Hmm.
this magnet
Magnet.
strength, I guess.
Yeah.
Uh,
Frequency.
yeah, that can reduce astrocytes, mind microglia proliferation, and increase C4 expression. I don't know what that means, but it does have, it does reflect cellularly, it does
Yeah.
really engender new cellular mechanisms. But again, what does all this mean? Is there like point A to point B, point B to point C? Can we describe this in a controlled environment? How is the word that how much can we, what like again, produce again and again? What is the word I can keep thinking reciprocating? Anyway, it's fine. I'm just not thinking.
So I bet this is gonna be so the other one that I would think comes up as frequently as deep brain stimulation, where they put an electrode into your brain and then they stimulate it similarly to control something, right? To control some brain function. My my bet is the mechanism is going to be somewhat similar, right? Um, in that you are modulating these neurons in a way that they're going to fire in a pattern that is specific to a quote unquote system, like the dopamine system, right? So you target that system and you can target the brain area. So for example, like it was an originally approved FDA for treating depression, like you
Yes.
mentioned your friend, right? So that's clinically what it's primarily built on is treatments for depression. And I'm sure they know specifically like, hey, if you're depressed, target this particular brain area. We're going to give it this paradigm of stimulation. And my bet, and this is what I've been trying to figure out is really definitive evidence to show that this is maybe dopamine systems, right? And the dopamine system, it's a little deeper brain
Mhm.
than just the cortex, but stimulating this nucleus accumbens dopamine nuclei sends dopamine throughout your brain, changes a bunch of different stuff, prefrontal cortex, right? It changes, it can regulate motor coordination. It does a lot of stuff. And so I'm curious if they've just found a way to non-invasively tap into modulating that broader system. And so as you've suggested, it's not necessarily a cell type specific thing, but it's just a system, like the dopamine system specific thing, right?
I was looking at what are the similar ways, what are the current existing therapies for like depression.
Hmm.
We have medications, of course, and we have ECT, electric convulsive therapy. So that is used for really very severe cases, shock.
Right. Right.
shock. And medications are for manageable, like of course it's hard, but still manageable cases. I think this TMS falls somewhere in between that, like the scale of medication
Hmm.
to the minimum and the electroconvulsive therapy to the maximum.
Yeah.
TMS fits somewhere in the middle. And it is not as, the effect of TMS is not as robust as electroconvulsive therapy. I read that in a study.
Okay.
With still better than lobotomy.
Yeah. Well, I mean, I think that's probably part of the reason for its growing popularity is if it doesn't work, like what are you out? An
Yeah,
afternoon, right? You've wasted some time and some money. I mean, you're not wasting um like nothing. Yeah, those could be valuable to a lot of people, but at
yeah,
the same time,
absolutely.
like if it doesn't work, then that may be that cost may be worth the potential benefit of it, relieving some depression. And I think one of the benefits, and this is we can get into this in a bunch of other different avenues, is but when the FDA approves an approach, right, it's almost like the public's experiment to see what
Yeah,
value comes from that, right? So now clinics can implement this. We can test different parameters. We can test different approaches. We can test different um, types of depression to see this works better in men than women. This this works better for this particular age demographic than this particular age demographic. When we start to really develop those details, that's when we start to really learn about it from a bigger perspective. And I think that's where, I mean, this came out early 2000s, I think. Spent 10 years studying depression, right? Helping and treating depression. And people figured out, does it work or not work? And, you certainly talk to people and they value it. So there's got to be some level. I'm sure some people works very well. Some people it doesn't work very well. Just like pharmaceutical approaches, right?
exactly. But I think better one advantage with the pharmacological approaches, with the drugs, you get a lot of side effects, man. It's like the
Mm,
thing that I've seen my friends go through with the antidepressive pills. It's bad. It's bad in the sense of course, it's not a targeted therapy, right? And the drug diffuses and goes to every part. It's not just brain. But I think TMS and electroconvulsive therapy, it's pretty robust and intense.
mm,
Sometimes you need to be medicated, you need to be put down, you need to even in hospital you need some recovery time after electroconvulsive therapy. And with drugs, of course, there is side effects. I think TMS fits in that sweet spot right in between. Of course, you need to go into TMS clinic
mm,
for that time, but then it's much more targeted. It's like a tiny targeted convulsive therapy to that particular part of the brain.
yeah.
But since it's not medicines, so of course you don't have that effect. But it does say that the side effects for these is, of course, you can't be wearing any metals, you can't be wearing pacemaker, any
Mm,
implantable
yeah.
devices, hearing aids, all that. I think it's a new way of looking into brain therapeutics and how can we how can we use new methods. It's like
Mm,
I think as classical scientists we are always trained like, okay, we do scientists, we find a drug, you need to take this drug and this is what it does, and okay, fine, like this injecting drug, pretty much, let it be venous, let it be taking chemicals in. I think scientists, we are conditioned to think like that. And I think this is a very new, controlled, and experimental approach.
mm,
I'm quite excited. I mean, if I'm going through this, I would, and if I have the opportunity, I would consider it.
yeah. Yeah, you bring up something that's pretty interesting. Like we are I would say trained is what the word I would use to um be skeptical of something until we totally understand how it works,
Yeah,
right? Meaning that we are as PhDs are trained to in biology, you're trained to get down to, I mean, we open this up with like, well, how does this change functions of cells? What cells, right? And to some, that's very valuable. I think it's very important. Um, but to some extent, like there are times when things will just work and nobody really cares why it works, how it works. but just that it works, right? And this may be one of them. We know a little bit, right? I mean, there's definitely, you know, publications and papers on taking cells in a dish, exposing them to some sort of repetitive magnetic stimulation, and doing the detailed physiology of it to show that this does this and this can affect GABAergic neurons this way and glutamatergic neurons this way, and nitpicking and detailing that. Those are things we can't really do in a human, right? We can't confirm that putting this cap on to this patient who has depression and targeting this brain region and the prefrontal cortex relieves their depression. But we can, or it changes the function of their brain in a way that is correlative to GABA is targeted, glutamate is targeted, dopamine is targeted, or whatever. But we can ascertain if it's making them better, right? Um, and I
What
think
is,
that's powerful, right? I think that's something we lose sight of as scientists, that there's benefits to that, and we don't always have to know, right? I mean, it's good cautiously to know, like, are there maybe negative side effects of it? But at the end of the day, if somebody's suffering from depression and it provides definitive relief, then there's value to that.
what did you think? Like when you heard TMS, okay, fine. You heard TMS, some wave something into the brain reduces depression. What did you think? Like what, like for example, when when I was going through that, the thing that I was thinking was, what does it do to the cells? Like,
Hmm.
wait,
I mean, that was my thought. I mean,
what
I
were
was
you?
like, I can theoretically put together how it would change a function of a cell, right? If an axon is a conductive conduit for current, there's going to be a magnetic um, field.
Yeah.
If you target it with a directed pulse of um, disrupting that magnetic field, you probably will change those voltage gated sodium channels that will then directly alter the function. That I can theoretically and conceptually put together. And I think there's a couple of papers that we found that demonstrate that to some extent, to whatever that can be. Like this neuron's firing, let's pump it full of electromagnetic wave and show that it changes its firing properties in this particular way, right? But it goes back to your question at the very beginning, is like, that doesn't, how does that mean? Like, what does that do to change your brain, right? And that's where I've been stuck, right? Do you look at fMRI data,
Yeah.
right? Do you look at, can you do that? I don't even know if you can do that. TMS in an MRI, right? Or if that's
It,
just too
isn't
much.
like a big TMS if you think about it? I mean, it's pretty much shooting magnetic pulses in the brain to scan it, right?
Hmm.
And I would assume that should be much more stronger than the shower
That's
head.
true. That's good. I don't know if it's at, I don't know the levels, like the frequency and the magnitude of that magnetic field, right? That's true.
But I think one thing is that one is a big pulse in a short time. I think TMS is you need to go there for 6 weeks.
Yeah, yeah. Yeah, I think of it as like these brain training
Yeah, yeah,
programs where you're like um trying to reshape the structure of your brain, right? So as if you're pumping in a magnetic pulse at a frequency, yeah, you're going to change the oscillations of those
yes,
networks. That's
yes.
going to ultimately change the structure of those networks, right? Those synapses are going to they're going to get stronger, right, to facilitate that movement. That movement, they don't move. The the oscillatory function. Um, that is like I see that as a structural change. You're going to have more dendrites, you're going to have more synapses in the cells that are incorporated into that network, right?
So in a very
Versus MRI, you're just like, brrr. and it's not a long enough stimulus to drive that
Mhm.
structural change. It may have an acute change, but it's not driving that structural change.
Take a very oversimplified and reductionist approach. So is TMS pretty much using magnet to control your mood?
Mm,
Magneto. like a joint mix of Magneto and Charles Xavier.
to control your mood.
I mean, isn't that I mean, depression is a mood disorder, no?
Yeah, I guess it goes into uh, what am I trying to think about? I mean, in a sense, right? I mean, I feel like mm, I don't know what I'm trying to think about. It's I think it goes back to this acute versus long-term changes of the brain, right? Meaning that like what does an oscillation in the brain do to represent depression? If you've got an oscillation in the brain
Can
that
you even
is
define
that
that?
is at alpha and beta, right? So let's say this oscillation, alpha and beta is like base level brain function. Brain at rest, brain active, like 8 to 30 hertz. Alpha is like 8 to 13, and then beta is like 13 to 30 hertz. Like these are like frequencies of oscillations that these neurons are firing together, right? That is not a depression thing, right? If you pulse it at 8 hertz, that doesn't put more alpha waves in your brain and make you more depressed, right? That is, to me, I mean, that's a big, interesting question for my own research is like, what do these oscillations mean for controlling function?
You know,
And I think that in terms of like how TMS is targeting the brain, that's what it's shifting. But I don't know how it's connecting to the disorder, right? Other than maybe these networks that then start oscillating at this one frequency are very prone to just changing dopamine, changing serotonin, right?
so these oscillations come from population activity, right? Of not just neurons, of other astrocytes, microglia, all these cells. But now that you say this, it just made me think that these basal states of oscillation, it is so different in when you are just idle, when you are thinking, when you are
Mhm.
sleeping, when you are in REM sleep, non-REM,
Yep.
and when you are doing this magnetic stimulation, and if it is controlling these oscillation states, I'm just thinking how would it look when we do the TMS during sleep?
Mm-hmm.
Is that more effective? Because then it's a different physiological state when you're in sleep.
Yeah. Yeah. Yeah.
And yeah, it's something.
Yeah.
What do you think? What is your verdict? Like, where do you, are you
Um,
convinced?
I am less skeptical.
Well, that is good.
I think I would agree with you in that if depression was something that I was battling with, I mean I said I have battled depression. Um, if it was something that I was unable to combat further, I would entertain it. I think for a couple of reasons. First, it seems like why not,
Yes.
right? I mean, you don't have to take anything out. There's nothing permanent about it at this stage. It doesn't seem like it. It's very reversible, meaning that it stimulates it. If you don't do it enough, it doesn't work. So there's some level that needs to be required.
True, that is true.
There's like no harm if it doesn't work other than you're not better, right? So I would be open to trying it.
I think it is more quote unquote scientific than many other methods outside. It's
Hmm.
more scientific. I'm sure it's more scientific than buying some crystals and leaving it there. And
Is that the next episode? Crystals.
you You'll get me canceled, Zain. Yeah, so yeah, okay. I think that's a
Yeah, I
good.
mean, I would agree. It's, I didn't know much about it before we started diving into the literature. Um, there's quite a bit. There's a lot of clinical data out there on it. There's not a lot of basic science on it, but as I said, I think people found that it was kind of non-invasive and pretty safe
Yeah.
and okay to move into clinical trials, and then it showed promise in clinical trials. I mean, I would not criticize anybody for saying let's move something translationally forward if we just because we don't have an idea of how it works, right? If it's demonstrated to be safe, time will tell. I mean, it's been out on the market now for 20 years, 25 years. Um, we'll know if it's effective or not, right?
I want to just segue before ending it to something that this made me think. This made me really think and ruminate on sonogenetics, where you can, like optogenetics, you control pop activity with light by expressing opsins. Chemo,
Mm-hmm.
of course, with chemicals, and sonogenetics with sound. It's in a lab, I think if I'm not wrong, in Salk Institute, and I saw the talks in SFN2 last time I went there. Pretty much you express whichever the Cree models and everything, and you express this receptor that it's a surface receptor that can open or close the channel based on a
Mm-hmm.
particular wavelength of the sound. And let's say GFAP Cree, astrocyte Cree, and you express that membrane protein over there. Based on a particular wavelength of the light, you can either activate or silence a cell. It it's very similar in the sense, of course, this is very vague, it's like just magnetic pulse. But if you have that transgenic machinery going on, then we can control not just population, but specific cell types
Mm-hmm.
in deeper regions of the brain too,
Mm-hmm.
whichever context. Since it is sound, it is not, you don't need to with optogenetics and all, you need to put the laser thing in. With chemogenetics, you need to factor in all the injection of CNO, yada, yada, yada. It's just turn on and off. And this is much more temporally controlled as well, like optogenetics.
Yeah, yeah, yeah. Yeah, that's I think part of my initial skepticism at the very beginning was also like, how would I have used this? And I don't know how to do that. Um, I can see a value for that. There's limitations towards non-invasive ways to modulate specific cell populations, neuronal cell populations in the brain. And the best we have is not as specific, with the dreads and the chemogenetics. This would give so what I mean is there's the temporal kinetics of that,
Yes,
right?
I
It's just down to the pharmacology of how the body would clear that compound versus this. You turn it off, it shuts off, right? I would think if this is legitimate TMS and helping people with depression and obsessive compulsive disorder and all these other things, there's gonna be physiological changes to a magnetic stimulation outside of the channel that you're trying to manipulate, right? I think that would be the confound is you would have to have a channel that was so sensitively um, activated, like you could put such a low level of magnetic field on it that it doesn't naturally change that cell's function. And I think that would be the limit, right? You might be able to do that, but I feel like that's the confound is that if this does work because it does change brain function, that's you're going to change brain function as well as alter the cells.
yeah. And maybe another thing to think about is heating up of the tissue too.
Eating.
heating,
Oh,
like,
heating. Yeah. Yeah, yeah, yeah. I don't know. I don't know if magnetic fields
right? Like,
um
like if something that produces this robust of an effort, let's say a fancy shower head with magnets attached to it,
yeah.
with this much of an effect, I can't think it's big. I mean, of course, there should be something happening, I mean, that it
Mm.
comes down to again, like another reason it seems a bit vague because there is not many strong studies based on it. And I think that's one way too, I guess, we
I mean,
study.
I guess it depends on what you want to do, right? I mean, I think the original studies that did this, they targeted the motor cortex. And so if you're trying to just like drive a behavior non-invasively, I think what they did was stimulate areas of the motor cortex and showed that it either changed the way you could move that that limb or that appendage or whatever they were doing, or it you could target the somatosensory cortex and show that like, oh yeah, I feel a tingling sensation in my hand that correlated to that part of the somatosensory cortex. Those things, I mean, you could technically do that on a cortical level. I don't know about the mouse or the rat, but um, you could target it that way, right? So like visual cortex, auditory cortex, frontal lobe, those types of things, and then selectively shut them down if they were trying to, instead of the crude old school way of like just zapping it with an electrical current and creating some lesion, you just kind of temporarily shut it down. So,
I hope this doesn't turn into one of those mumbo jumbo fad. You know what I mean? Like, I hope this something actually,
hmm. What would you define what has turned into a mumbo jumbo fad?
like, talking about like these crystal energy things and just,
I think those started off as mumbo jumbo fads. Right.
right, it's just, I don't know.
I don't know. I
But
mean, it seems like it's been around enough. There's been enough popularity in it. It's still around. I think like with most things, there's going to be some basic level of effectiveness. Some people are going to respond to it. Some people won't respond to it. Right. I think the value of it is that that's the same thing with like resecting brain tissue, right? There's some people that respond to that, right? Um, their surgeons nowadays are pretty good about defining who would be a good candidate for surgery to remove that part of the brain, right?
I wonder what makes them though. Anyway.
But some people, it may, it works very effectively. Some people they have to define if they're a good candidate or not, and they know nowadays what makes a good candidate or not a good candidate. And I think same kind of thing. Everybody's individual brain is going to be responsive to this treatment, right? Not everybody responds to SSRIs the same way. Some people don't even respond to this, SSRIs the same way. Like if you take escitalopram, you may respond to it differently than I did, right? You may need, a different SSRI. So,
Oh, well, I think.
hey, any final thoughts? What is your verdict? Yeah, I mean, you said you'd do it. Did
Yeah,
it
I
change you?
would, in a sense, like, why not, right? What do I have to lose? Like, I personally think, um, again, like I was saying, antidepressants, medications, of course, it's riddled with side effects. And it's also,
Mm,
like, just you said, many people don't respond well to antidepressive medications as well. And electroconvulsive therapy, it's like Frankenstein level shit. No, thank you. But
mm.
one, if it is affordable and if it is, if it's available too, why not give it a try? If it works, it works. Great. And if it doesn't, it's just a magnet on the head. We don't know the long-term effects of it, but still, it's just a magnet on the head for now. And
Yeah, 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 yeah. I think that's the experiment that we're in, right? That's
yeah,
what the experiment that the FDA is running on us right now is. It is safe in the short term. There's no immediate consequences, negative consequences. The only way we can understand long-term side effects is safe now. Let's see what happens in 30 years, right?
Yeah, more people doing it, I guess.
Yeah. I mean, that's what happened. I mean, that's just how things go. That's how we determine.
Fair, that's fair. That's what happened with COVID vaccine too. Oh my God, let's not say that. I don't want this podcast to be banned. All right. I think we got
Okay. Yeah, thanks, Gopu.
you, Zane. It's a good recording. I think we can close it there.